Hello student, how are you? I hope you all are doing good. I am Pooja Tripathi, your teacher. So student, numbers are everywhere, all around us. In a real life, we use numbers. So in this chapter, we are going to learn about the numbers. So let's start the chapter, A Story of Numbers. Our learning objective in this chapters are introductions to number system, foundation, idea behind counting, a look back at early counting method, a revolutionary concept, understanding number base, understanding place value, the main number system, and the ultimate evolution, the Arthimo-Hende number system. So we are going to start with the introduction to number system. In the warm-up activity, you notice how Roman numerals look completely different from the numbers we use today. You know, in Roman system, we use symbols only. There is no place for zero. This raised an interesting question. Why did humans shift from ancient numeral system to more efficient system that used in the digit of 0 to 9? Behind this transformation lies the fascinating history and the remarkable story of the human progress. Let us take the journey through the evolution of numbers. Why people need counting? Now, what is the use of counting? Why people need it? So, the use of the numbers is almost as old as the human existence. So, numbers are as old as the human exists. Even thousands of years ago, long before the written language was developed, early humans needed simple method to count and keep the track of things. This helped them to manage daily life. Some important reason to counting ancient times were keeping record of gathered fruits, grains, and other food. For that they need numbers, monitoring the numbers of the animal in the group or flock, exchanging the items during the simple form of trade, maintaining record of object or the offering during the cultural and religious practices. Counting also played a key role in measuring time. People observe repeating natural events such as sunrise and sunset and changing the shape of moon and the seasonal changes to understand the passage of the day of month. It helped them to decide the best time of hunting, farming, and preparing for the weather changes. Although human always needed numbers, the way numbers were written has changed drastically over the time. Different communities across the world created their own method to show the quantities. The long process of the development eventually led to the number system we use today. So this led to the development of the number system that we use today, known as the Hindu-Arabic numeral system. The Stone Age referred to the early stage of the human history when most of the tools and weapons were made from the stone. It was during this period the people first began forming the basic idea of counting. The Hindu-Arabic number system, an expanded historical overview. The digit we use every day, 0 to 9, seems so ordinary and effortless that it is difficult to imagine the world without them. Yet the number system has a long and the extraordinary journey that began many countries ago in the ancient India. Early Indian scholars developed the highly organized way of naming and writing the numbers, especially using the idea of the power of 10, which became the foundation of the modern place value system. Now, ancient Indian texts such as those found in the early Vedic literature already displayed an immersive method naming the number in the systematic sequence. So, early Indian number names based on the powers of 10. Indian scholars did not restrict themselves to naming only small values. They created structured name for the continued large number. For example, like for 1 they use ekam, for 10 they use dasha, for 100 they use satam, and for 1000 sastram, and 10,000 ayutam. These names continue for the much higher power of 10, well beyond the 10 is to power 11, and into the extremely large values, showing a deep understand for the place value and numerical expression. This revealed that the ancient Indian mathematicians have already established the foundation principle of the base of 10 and positional number system long before many other civilizations. So, understanding CE and BCE. What is CE? Common Era. Refers to the year starting from the year 1 onward. For example, 2026 CE. Now BCE, before the Common Era, refers to the time before year 1 counting backward. These terms help historian and researcher describe time without using religious label. The discovery of the digits and zero. The greatest milestone in the history of number was the creation of the symbol of now recognized as digits. Among these, the concept of zero was revolutionary. So, the most important discovery was the concept of zero. Early record shows the zero first appeared in the small dot in the ancient manuscript. Evidence to this concept can be traced back around the 3rd century CE in India. The system gradually evolved and the Indian scholars developed clear written form of all 10 digits. Around 1500 years ago, scholars such as Aryavarma explained the advanced calculation techniques using these digits, strengthening the use of the place value system, Hindu-Arabic number system. The Indian mathematician who created the digital concept of zero and the position system. The Arab scholar who spread these ideas to the rest of the world. Eventually, this efficient system replaced by the bulky and inconventional Roman numerals. Its adaptation helped to transform science, trade, education and navigation and mathematics across the world. Though the Hindu-Arabic numeral system is now the standard way of writing numbers across the world, it is only one among the several number systems created in the different civilizations over time. To appreciate why the system becomes so efficient and widely accepted, it is useful to explore other numerical methods people once used. So, other methods are foundational idea behind counting. What was the foundational idea? Long before the human used familiar numbers such as 1, 2, 3, people still need the way to keep track on the object, animals and the daily resource. The concept of counting did not start with the symbol. It began with the simple, clever method created by the early communities for the survival. How counting first developed? So, can you imagine how counting was first developed? Imagine the small group of ancient people living many centuries ago. They had no marks, symbol written on the numerals. Despite of their everyday life required careful observation and record keeping, they faced practical questions such as how many fishing tools do we have for tomorrow expedition? Did another tribe gather more fruits from the forest than we did? How many clay pots must we make before the rainy season starts? So, keep track on all these things. They need numbers. Without the formal number system, they devised the basic counting technique based on the matching, comparing and creating sequence. One of the earliest ideal or one-on-one correspondence, which later became the backbone of all number system. So, method 1, matching object with marks. The simplest approach was to pair each item with the physical token. For example, for every fishing hook a person made. So, here they express with the picture. For every fishing hook a person is made and might place a tiny shell into the woven basket. Whenever the group wanted to check their tools, they simply compare the shells to hook. If every hook matched with the shell, the count was correct. If the shell remained unmatched, they knew something is missing. So this is how they keep track on the things. Now this system worked well for the small collection but became difficult for the larger quantity. Now carrying 50, 80 or the 100 shell was inconvenient and risky. Token could be lost, mixed up and damaged. So next method, using the set, sequence and sound to count. To avoid carrying physical objects, early humans create a fixed sequence of the meaningful sounds. Instead of the symbol of numbers, they use the pattern to pronunciation for the counting. Imagine using syllables like first 10 KA, second 10 LO, third 10 MI and fourth 10 SA, like this. So number of squares and representing letters. So here they are representing numbers with the letters. By speaking each sound in order while checking items, the last sound spoken indicate the total count. This method introduced the idea of order sequence to feature essential of all modern number system. Now method 3, recording number with the simple drawing and marks. Over time, humans begin making permanent visual marks to represent quantities. They carve symbols into wood, bones, stone and clay, allowing to count to be remembered even after the days or the seasons. Many early symbol systems exist. Is one well known example is ancient numeral script used in early European civilization, where letters stood specific values. Here you can see a table. Here for every number there is a symbol. Symbols are used to write the numbers. Like in Roman system, you know, although these symbols system worked, they often become complicated for every large quantity representing number in the hundreds and thousands require long string of symbols, making writing and calculation slow. Now, what these early method taught us. So, what these method taught us, whether people use shells or stone as token, spoken syllables or the carved symbols, they all relied on the central idea. Counting need an order pattern that everyone follows. Just as the letter follow fixed order, like B comes after A, C comes after B. So, this is order A, B, C, D. This is the order that is followed for the alphabets. Numbers also follow the standard sequence like 1, 2, 3, 4. This idea to creation of the complete number system. Now, qualities of the good number system. Designing the useful number system is not simple. A strong and practical system must be extend without the limits so that the quantity, no matter how large, can be written and understood. Be quick, simple and efficient, allowing easy writing, comparison and calculation. The modern numeral system is used today evolved because it meets these requirements better than the earliest method. Number system numerals, although they appears similar, a number system and the numerals are not the same. So, number system and numerals are not same. That we have to keep in mind. Think of a number system as the complete language with grammar and rules, while the numerals are just the symbol of the combination of symbols used within that language. For instance, consider the quantity that So the number system and the numbers are different. So that we have to understand the difference between them. So, for instance, consider the quantity that we commonly call 12. The idea of 12 does not change. It is the same amount everywhere in the world. Now, in the Hindu-Arabic numeral system, This quantity is written using the numeral 1 and 2 to form 12. In the Roman numeral system, the same quantity is written as XII using the symbol to represent 10 and 1. So, although the quantity is identical, the symbols and the rules used to write them differ depending on the number system. So, in different number system, the way of writing numbers is different. Now, we will take an example here. A village leader wants to keep track on how many households have delivered their annual bundle of grains. After counting, to find 14 families have paid their share. By writing the quantity as XIV using the symbol system more useful than writing or storing 14 stone, method 1, or relying on the 14 in spoken sound, method 2. So, the solution is the greatest advantage of writing the number as the using symbol and written mark serve the long lasting and easy to store record. So, that is why that is more efficient to write like this. Now, comparison of method using the physical marker method, stones and tokens. Stones can be misplaced or lost leading to incorrect count. Sometimes it may be happen that stone can be lost, so we will not get the correct idea. Carrying the large number of stone become the bulky and inconvenient. The small error, dropping and adding one stone, can change the count. Using the sound or the counting word, that is the method 2. We have read earlier, spoken words vanished immediately, cannot be rechecked later. Very large counts require long sequence sound, and the sound may be forgotten or skipped, causing confusion. So, using written symbol, that is the method 3, the written numeral on the clay, barks or the wood can be preserved as for years. So, we can preserve it for the years. The compact symbols communicate the quantity clearly and quickly. Written marks provide accuracy as they do not change unless altered. Learning point 3.1, all these questions you have to practice. Next is a look back at early counting method. In the previous sections, we understood why humans needed counting and how one-to-one matching helped them to keep track on the objects. But as human group become larger and their activities more complex, managing livestock, storing grains and tracking trades, counting singles items one by one no longer practical. For example, keeping one marker for each cow become extremely inconvenient. When the herd grows to 100 animals, carrying 100 stone or shells simply wasn't realistic. This difficulty pushed early societies to develop more efficient technique. One of the most important breakthrough was the idea of grouping. Counting object not just individually but the fixed bundle grouping allow people to handle the large quantities as far as fewer symbols, the markers, leading to the early foundation of the number system. Next is counting system based on the tally marks and grouping. Using the human body as the natural counting device before writing, before token and long before modern numerals. Every person has a built-in counting tool. The human body finger provided the earliest and the simplest counting method. But different cultures extend this idea creatively and reach much larger number. One fascinating method used traditionally in the parts of Asia and the Middle East involved the counting using the segments of the fingers. So here we use the segments of the finger, not just the fingertips. Here is how it works. The thumb acts as the pointer or the counter. So we use thumb as a pointer or the counter. The thumb touches each of 3 bone segments like this, and the other 4 fingers. Index finger 3 segments, middle finger 3 segments, ring finger have 3 segments, and the little finger also have 3 segments. Since there are 4 fingers and 3 segments in each total, so total 12 segments, the person count up to 12 using just one hand. This method provides several advantages. This requires no external tools like the stone or stick, the portable and always available. It allowed quick counting during the trade and outdoor activities, but the system didn't stop here. To count higher number, once the right hand complete the cycle from 1 to 12, then the person would lift one finger on the other hand and show the one group of 12. Then they would begin counting 1 to 12 again to the first hand. Since the left hand have 5 fingers, this method allowed 5 groups, 12 each, total 60. This is an early examples of the base 12 and base 60 system derived from the simple body based counting. Now, why these systems were useful but not perfect? These body based methods were practical and clever, but they had limitations. So, what are the limitations? They could not store information permanently. They require the counter to be physically present there. They could become confusing when dealing with the very large quantities. Nevertheless, these early approaches played a crucial role in inspiring the development and written numerals, an organized number system used later by the ancient civilization. Tally marks on the surface. As human societies advanced, they needed the way to record numbers. With the development of the things, they started counting the things, and they need to keep the record of that. That did not depend on the memory or the body gesture. One effective solution was to make tally marks. So, the solution they find, that is the tally marks, simple lines cut and the solid surface such as the bone, wood, stone or the walls of the shelter. These marks serve as a lasting record, much like writing on the paper today. Unlike pebbles and the finger counting, tally marks did not get lost or forgotten. Once a mark was carved, it stayed there for days, months and even thousands of years. Once it's carved, it will long lasting, for it can stay there for the months, days, years and thousands of years, allowing people to keep long term record of animal harvest, depths and the important events. Now, examples of ancient tally system, the prehistoric counting bows. Archaeologists have discovered many ancient objects covered with the tally marks. One remarkable example is the prehistoric animal bone found in the Central Europe. The artifact is estimated to be roughly 10,000 of years old and contain around 50 marks of the group of set of 5. Here you can see the wolf paw of Turney Western. So, people use the tally mark to keep the record of the numbers and the things. Here the grouping clearly shows. Here you can see the tally marks, the lines shows that the early human were not only counting individual items but had already developed the idea of bundling numbers to make large quantities easier and manage. This is an early sign of mathematical thinking long before written numeral exist. Now, the traditional tally sticks. Another long lasting method of quantities was the tally sticks, widely used by the herders, traders and even governments of the different parts of the world. The shepherd could cut one notch in the wooden stick and for every animal in the flock. The stick then acted as a record to could not be easily altered or erased. This idea becomes especially important in the trade. When the loan and the finance agreements was made, the wooden stake was carved with the notches representing the amount owed and was then split lengthwise into two matching halves. One piece kept by the lender and the other piece was kept by the borrower. This helped them to keep the record. Because the grains of the wood matched perfectly in both halves, neither party could change the number notches without being detected. They made the tally stakes an early form of secure tamper-proof contract. Grouping by single base additive principle. Many early number system was built on the simple idea of repeatedly adding a fixed group size. The widespread group method used 5 as the main unit. They use 5 as the main unit because humans naturally have 5 fingers. We have 5 fingers in one hand. On one hand, this led to the number names being formed by adding smaller quantities to the base value. The good illustration of the idea appear in the traditional number system spoken by the certain communities of Central Asia. Their number names are formed in the clear base 5 structure where they term for the 5 form or the formation or foundation of building larger values. Now the examples of base 5 patterns. Here the quantities, number in words and meaning, like 1 koro, that is for 1, 2 lami, that is for 2, salu for 3, tiri for 4, Macau for 5, Macau ka 5 and 1, Macau lami, that is 5 and 2, and Macau sulu, that is 5 and 3. Using the pattern, the number 8 is expressed as the 5 plus 3. Now beyond the 5, creating word for the larger groups. Now what about the number beyond 5? When number become too long and expressed in the relatively adding units to 5, new words were introduced to important checkpoint. The example net fortified. The term for the 10 might be term. For the 20 could be misu. These words made it easier to describe the large count of endlessly repeating 5 and how connectors work. Two different connectors are used in this. So, two different characters are used here. The smaller character ka is used when adding unit 1 to 4 to 5 and Macau ka 5 and 1. The main characters such as ra that link larger grouped numbers, that is for larger group numbers like 10 or the 20 with the additional units. Now Dewan Ra Koro 10 and 1, Mesura Lami 20 and 2. This make the system functional but still lengthy. Now what are the limitations of the pure additive system? Although the base 5 additive structure is more organized than the basic tallies or pebbles, it become very slow and repetitive as the number grew larger. As the number grew larger, it becomes slow and very repetitive. The example expressing 23 in such system might look like this much. The number increase, the spoken and expression become longer and the more complicated. Writing also become bulky because there is no compact symbol. This difficulty highlights why later systems such as the Roman numeral with the multiple fixed symbols was significant improvement and why positional systems like the Hindu-Arabic numeral eventually become dominant. Now the strength and the weakness of the grouping systems. The idea of grouping numbers as seen earlier in the various base system was not limited to one region. Many ancient cultures around the world discovered on their own and counting become the easier and the qualities are collected into fixed group instead of counting one by one. Different society chose different group sizes depending on what made sense to their daily life. Some communities, such as those in the part of Central Africa, the group of 5 inspired by the 5 fingers of the hand. Central Island group of Northern Australia use the system built on the pairs. They use the system built on the pairs base of 2 structure. The people in the ancient Egypt used 10 as their foundational likely pickers. Both hand together provide the natural group of 10 fingers. Civilizations in the Central America, such as the one in Mexico, often use the 20 combining finger of toes. They also take the finger of our hand and toes. So, total 20 fingers. Despite a variation in the same idea was the work, grouping numbers make counting faster and more reliable than dealing with the single mark or scattered objects. Now, why grouping was improvement? Human brains can quickly recognize small collections like 2, 3 or 4 items without counting them individually. But when the number gets larger, ungrouped items become difficult to manage. Organized object into uniform bundle of groups allowed early people to count more quickly, avoid mistakes and keep track on the large quantities with less effort. This was the major step forward from the simple tally marks or the individual pebbles. The main weakness of the single base system, what was the main weakness? Even though the grouping made counting easier, system built the only one group size. And serious drawback, they become the long, repetitive and inefficient for the bigger numbers. For example, the pure base 5 additive system, the number 100 would have to be expressed as 20 groups of 5. So, to express number 100, we have to use 20 group of 5 or written out using 20 repeated symbol. This is slow, bulky and impractical. As the number grew, the language or the symbols needed to express them become increasingly complicated and the time consuming. The next breakthrough to overcome this problem, later number system introduced multiple group sizes, each with its own symbol. The Roman numeral system is the perfect example. It used several values for 1, 5, 10, 15, 100 and so on, and allowing people to represent the larger number much more compactly. This shift from the single base to multiple symbolic unit marked the major leap in the development of the efficient number system. Now, the ancient Roman number system. One of the major improvement in the early number writing came from the system developed by the ancient Roman, and unlike earlier counting method that relied heavily on the repeating the same symbol again and again, and Roman system introduced a smart way to representing the number using the symbols for specific milestone values. These milestone values acted like anchors that made writing and reading numbers much easier. Instead of writing the a small symbol repeated, the Roman cleverly used the symbol to represent larger quantities. Now, main Roman symbols and their values. The Romans selected special letters to stand the important values. These acted as building blocks for their number system. You can see the table. For every number there is a symbol. I for 1, V for 5, 10 for X, for 50 they use L, 100 they use C, 500 D and 1000 M. These symbols allowed people to write very large numbers without long string of repeated marks. How the Roman system forms numbers? Roman numerals followed the major rule that position the smaller symbols play the key role of deciding whether to add or subtract values. So, there are certain rules which we have to follow while forming the Roman numerals. First is the additive principle. When the smaller value comes after the larger value. If the smaller value after the large value, both values are added. Like xii, 10 plus 1 plus 1, that is 12. Next is subtractive principle. When a smaller number appears before the larger number, its value gets subtracted from the larger number. This rule reduces the repetition. The example, instead of writing I, Roman write IV. That means 5 minus 1, 4, ix, 10 minus 1, that is 9. These two principles made possible to write both small and large numbers efficiently. Now we'll take an example here. Convert 34 to Roman numerals. So first we'll break down the number, break 34 into parts, 30 plus 4. Convert each part, 30, that is xxx, and 4 can be written as IV. So this is how we are going to represent number 34. So you have to practice all the examples given here. Now, where Roman numerals are still used today? Even though Roman numerals are no longer used for arithmetics, they continue to appear in many places. You may see them on the face of the traditional clock, in the titles of the movie and the major sports event. You can see the Roman numeral in book chapters and the volume numbers, in the name of leaders such as King Richard III, on the building to indicate the years of construction. Their use give the classical and the elegant appearance to the text or object. Why the Roman system was useful? The main strength of the Roman numeral system was its clever use of symbolic milestone. For example, writing L for 50 is faster than writing XXX 5 times. Writing C for 100, avoid writing 10 X's. This made the system practical for the record keeping numbering and inscription of the hundredth of year. Many regions across Europe relied on the Roman numerals for everyday use. Next is learning point 3.2. You have to practice all the questions given here. Next is understanding number base. The numeral system, an important step of the history of mathematics, by using the distinct landmark symbols such as V, X, L, and allowed the people to represent the number beyond single digit. However, the system is a major limitation. Performing calculation was cumbersome. For instance, multiplying the number like CLII or LXIII required intricate procedure that only trained scribe could manage. This limitation highlights the need for the more efficient method of counting and calculation. The next significant advancement in the numeracy came with this simple and powerful concept, the idea of the base. Rather than using unrelated symbol for important number, mathematicians imagined the system where all symbols are connected to predictable structured way. The approach led to the foundation of modern number system. This led to the foundation of the modern number system. The ancient Egyptian system, an early base 10 approach. On the earliest known examples of the based system comes from the ancient Egypt. All these comes from the ancient Egypt, developed around 3100 BCE. Egyptians naturally choose 10 as their base. So they chose 10 as their base, likely inspired by the 10 fingers of the human hand. In this system, each landmark number corresponding to the power of 10. The Egyptians created unique hieroglyphic symbols for each power of 10. These symbols often represent the familiar object, animals, and mythological ideas. Now making the system visually intuitive. For example, 1 was a single stroke, 10 was represented by the heel of bone. Here you can see all these are used. All these symbols are used. 100 was shown as the coiled rope. For 100 they used a coiled rope. 1000 took the form of lotus flower. Now examples, writing numbers using Egyptian symbols. So how they write the number using these symbols? Suppose we want to write a number 726 in Egyptian numeral. The first step is to break it into the 10 component. 726 we can write 700 plus 20 plus 6. In Egyptian numeral, 700, 7 symbols of 100, that is coiled rope. So symbol for 100 is coiled rope, so 7 symbol of that coiled rope. 22 symbols of 100, that is heel bone, and 6 single stroke. Since the system was additive, the symbols could be arranged in any order without changing the total values. For larger number, Egyptian also used the imaginative symbol. For instance, 10,000 was depicted as a finger, 1 leg as the tadpole, and 10 leg for a man with a raised arm. For this they use a man with a raised arm, symbolize the concept of infinity. So these symbols they used on an unimaginably larger quantity. This structure based 10 approach made it easier to understand the numerical relationship even if arithmetic was still manual and time consuming. It was a procedure to the position number system that would later revolutionize mathematics. Now understanding the base number system. While the ancient Egyptians used 10 as their base, the idea of the base is much more. So they used 10 as their base, but what was the idea behind it? Flexible. In fact, any whole number greater than 1 can be served as the foundation of the number system. This powerful concept can be generalized to create what it called the base system, where the n represent the chosen base. Let us explore the idea of imagining base 4 system. The base 4 system, each landmark number is the power of 4. Here you can see power 4 is 0, so value is 1. If 1, then value is 4. So like this, the base 4 system, power of 4, base 4 system, and the power of 4 is used here. Now advantage of using the base number system. So what are the advantage of using these system? One of the greatest benefit of having all landmarks numbers powers of the single base become obvious when they perform arithmetic operation. Organizing numbers in the base system simplify addition, subtraction, multiplication, and even more complex calculation. Now simpler addition. In the base of the system, addition become straightforward because similar symbols can be grouped and regrouped when necessary. Now, for example, imagine an ancient Egyptians like base 10 system. If you have 12 one symbol, you can regroup 10 of them into the single 10 symbol, leaving with the 1 10 and 2 1s. So this is how you can write. This process is equivalent to the carryover method used in the modern addition. So this is just like the carryover we used in the addition. 12 plus 5, that is 1 10 and 7 1s, that is 17. By organizing the numbers into the power in the base, we can perform addition more efficiently without manually counting each unit. Next is systematic multiplication. Multiplication also become more predictable in the base system. The product of any two landmark numbers always result in another landmark number. For instance, the base 10 system, 10 into 100, that is 1000. In an Egyptian like notation, a heel bone, that is 10, that is used for the heel bone, 10 multiples of the coil of rope. For the 100, coil of rope is used for 100, equal to the lotus flower, that is for 1000. Compare this with the Roman numeral system. Multiplying VXL, that is for 50, works fine. But multiplying V into L, that is 5 into 50, 250, has no single landmark symbol, and making calculation crimpus. Thus, using the base system make both addition and multiplication systematic, predictable and scalable. Here we will take an example, add the following. So, here we are adding all these symbols. 11 single stroke is equivalent to 1. 1 is for 1, 11 is for 11. And 1 heel bone and a single stroke. So, 6 single coiled and rope cannot make the next base 10 member Egyptian number system. Hence, this will be equal to this. Here the single stroke, that is for 1, and the heel bone, that is for 10, the coil, that is for 100, and lotus. These symbols are used, and this is how we are going to add. So, practice all the examples. Now, limitation of the early base system. What are the limitations? Despite of its advantage, the Egyptian base 10 system has limitation. It requires an endless supply of unique symbols for very large numbers. To write the trillions, the new symbols would be needed. And for quadrillion, yet another symbol would be required. To write quadrillion, yet another symbol would be required. For writing these numbers, we know we need more symbols. This challenge is inventing new symbols of every large numbers mean the system could not easily handle extremely large values. The stage for the next breakthrough. The idea of the base laid to the foundation of the most significant breakthrough in the history of the number. The new system solved the problem of infinite symbol and made arithmetic operation, even with the enormous number, much simpler and more efficient. It paved way for the position of number system, which formed the backbone of the modern mathematics and computing. Next is learning point 3.3. You have to practice all the questions. Next is understanding place value. Now we will understand the place value. The most significant breakthrough in the history of numbers was the concept of place value. This idea shows that the position of the symbol could determine its value, solving the major So, this idea showed that the position of the symbol could determine its value, solving the major problem in having the invent and endless numbers. Of the new symbol for the very large numbers with the place value, arithmetics become more powerful and efficient. Now, the Mesopotamian Babylonian system of base 60. The first known civilization is used a place value where the ancient Babylonians who lived in the Mesopotamia over the 4000 years ago. Their numerical system was revolutionary but unusual because it used a very large base, that is 60. Although the base of 60 might seem strange today, it have the practical advantages. The number 60 is highly divisible. It can be divided by 1, 2, 3, 4, 5, 6, 10, 12, 15, 20 and 30. This made it ideal for the trade, astronomy and fair division of quantities. This practical benefit is likely why traces of the Babylonian system survive today. Now, writing numbers from 1 to 59. The Babylonians were remarkably efficient. To represent the number from 1 to 59, they only need two basic symbols. the vertical wedge to represent 1 and the side wedge to represent 10. The vertical wedge, that is for 1, and the horizontal wedge are to represent 10. They combine these symbols using a simple additive rule. For example, like this, they have written the numbers to represent the number from 1 to 59. Now, representing large number. Writing numbers up to 59 was a straightforward, but the larger number like 100 or 640 required the additional strategies. Use the landmark numbers such as the 1, 10, 60, 360 and so on. These numbers could be combined to represent much larger quantities efficiently. The system evolved into the true position number system, where the position of the symbols indicate the multiples of the 60. For instance, the first position represents the multiples of the 1 and the second position multiples of 60 and third for 60s and so on. Next is legacy of Babylonian system. So, even though the Babylonian based 60 system ancient, the influence of is still visible today. Time measurement in weeks, 60 seconds in a minute and 60 minutes in an hour. Next is geometry, 360-degree in a circle. The Babylonian system demonstrated the clever combination of base numbers and the position value that could solve the limitation of the earlier number system and allow arithmetic with extremely large numbers. The Great Leap, dropping landmass symbols. The Babylonian made an extraordinary leap in the mathematics by eliminating separate landmark of the symbol, the power of 60, instead of creating the new symbols of 60, 300, 3600 or 2,16,000. They realized that the position of the numeral itself could indicate its value. This meant to the same symbols used to represent the number from 1 to 59 could now handle extremely large numbers simply by using the place value. The rules for the position were: the rightmost position represent the ones, rightmost that will represent the ones. Now, the next position to the left represent the groups of 60, the following position of the left represent group of 3600, 60 into 60 and so on. By relying on the position value, the Babylonians simplified their system and reduced the number symbols required. Here we will take an example, writing 5340 in the Babylonian place value system. So, first we have to break down the number. So, we can write the number like this. Now, 3600 place 1 symbol, 60 is place 29 symbol, because 29 into 60. So, we need 60 symbols for 29 and 1's place 40 for this. So, the result will be this. This process is similar to the extended form used in our modern Hindu-Arabic system. Babylonian base 60, 5340. So, first we will break down the number like this. Now, Hindu-Arabic base is 10. So, we will write 5 into 1000 plus 3 into 100 plus 4 into 10 plus 0. The core idea is the same. Each position represents the power of the base and the symbol indicate the multiples of their power. Now, the problem of the missing 0. The Babylonian system had one major flaw. They initially had no symbol for 0. In Babylonian system, there was no symbol for 0 if a position was empty. They simply left the blank space which could cause confusion. So, here we will take an example, writing 3625. So, we will write like this. Without a 0, they would write like this. They will leave the space for 0. But the same symbol could also read as 85, 1 into 60 plus 25 if the blank space was unclear. To solve this later, Babylonian scribes invented placeholder symbols, often two symbol slanted wedges, to indicate the empty position of the middle number. For example, using the placeholder 3625 written as like this. Now it is clear. So for that 0 they have used the symbol. Now limitation of incomplete place value system. Even with the placeholder, it was not a true 0 because it was never used at the end of the number. This led to ambiguity. The number 1, number 60 and number 3600. Without the placeholder at the end, it was impossible to distinguish these numbers without context. The limitation highlighted why the invention of 0 was one of the most important milestone in the history of the mathematics. 0 complete the position number system, enabling ambiguous representation of any number no matter how large. The Mayan number system. While the Babylonian made great advantage in mathematics, the system remained incomplete due to the absence of the 0. On the other side, the world in Central America and Mayan civilization independently developed a highly sophisticated place value system. So they have developed a place value system. Most importantly, they introduced the true placeholder system for 0. That was the lacking in Babylonian system, solving the problem that has puzzled the mathematician for millennia. Now, a system of just 3 symbols. The Mayan number system was remarkably efficient using only 3 basic symbols. Dot that represent 1, bar that represent 5 and shell that represents 0. Number from 1 to 19 could represent combining dot and the bars in the single horizontal block. To represent the larger number, the Mayans used vertical stacking. Each horizontal block corresponded to a place value. The bottom block represent ones and next block will represent the 20s and then 316, then 7200 and so on. The vertical space between the blocks separate the level and prevent confusion. Mayan landmark numbers. The Mayans use specific multiples as landmark. 1, that is 20, 20 into 18, 360, 360 into 20, that is for 7200, like this. As you can see, the almost base 20 system. So base is 20 with the slightly adjustment at the third level, multiplying 18 instead of 20 to align with their calendar system. Now, how to write numbers in the Mayan system? Step 1. Break the numbers into main place values like ones, then 20s, 360 and 7200. Now, determine the quantity at each level. Number of bars, divide the quantity by 5. Number of dots, remainder after dividing by 5 and use the shells. The quantity is 0. Now, step 3. Stack the symbols vertically with the lowest place value of the bottom and the highest at the top of the shell. Symbol ensure that the empty level are clearly represent, avoiding ambiguity. Now, example representing the number 824 in the Mayan system. So, first we will break down the number 824 Mayan place value system. 4 ones, 1 into 20, 1 bar and 360s, 2 into 360, 2 dots. Stack vertically from the bottom to top, top to middle bottom. This approach allows any number, no matter how large, to return with just 3 symbols. So, they use just 3 symbols to write all the numbers. illustrating the brilliance of the simplicity of the Mayan number system. Now we will take an example. Write the number 41. So first we will break down the number according to Mayan number system. 2 into 20 plus 1. Second level 20 place 2 dots. Bottom level 1 place, that is for 1 dot. So this is how we are going to represent the number. So practice all the examples. Next is Mayan representation. Top, middle and bottom. This format shows clearly how the Mayan system used dots, bar and shells with vertical stacking indicating higher place value. It also demonstrates how place value and the zero place folder allow the representation for any number efficiently. Now the power of unique feature of the Mayan system. The introduction of the shell symbols for the zeros was the major invention in the Mayans. So the shell system for the zero, that was the major innovation for the Mayans. It complete their place value system, allowing any number large or small written clearly and emotionally. This made the Mayan system one of the most sophisticated numerical system in the ancient world. However, the system was not pure base 20 system, and the first two places. Now, however, the system was not a pure base of 20 system. The first two places value are 1s and 20s, followed the base 20, but the third place was 360, that is 18 into 20 instead of 400, that is 20 into 20. Historians believe that the adjustment was intentional, aligning the number system with the 360 days Mayan calendar. To adjust that calendar, they have made these changes. This made the system particularly useful for the timekeeping and astronomy, even if it was slightly irregular and pure arithmetic calculation. Meanwhile, the other parts of the world civilization, and such as the ancient Chinese, independently developed a place value system using the counting rods, demonstrating that the concept positional numbers was discovered in multiple cultures. Meanwhile, in other parts of the world civilization, the ancient Chinese independently developed a place value system using the counting rod, demonstrating that the concept position number was discovered in the multiple culture. By the stage of history, three major breakthroughs of the numerical thinking had emerged. The concept of base, introduced by the Egyptian, the place value that pioneered by the Babylonian, and the true zero placeholder that invented by the Mayans. These innovations collectively laid the foundation. All these three that laid to the foundation for the modern number system we use today, combining the base, position, value and zero representation any number efficiently. Now the ultimate evolution of Artho-Hindi number system. Throughout the history, humans have refined the ways to count and record numbers, moving from the basic telemarks to the sophisticated concept like base, place, value and zero. That perfectly integrate all these innovation is known as the Artho-Hindi number system. The variant of the Hindu-Arabic system and forms the foundation of modern mathematics worldwide. This system power comes from the three key features. 10 simple symbols. Only 10 digits are used, like 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. These symbols represent any number. We can represent any number using these symbols regardless as of size, making the system highly versatile. Next is position value or the place value. The position of each digit determines its value. For example, the digit 6 in 60 is different meaning than 6 in 600, 6 in 1000. Each position corresponding to the power of 10, giving the system compact and efficient structure. A true 0, a digit 0 serves two essential purposes. As a placeholder, it removes the ambiguity of the number like 204 or 1005. As an independent number, it participates in the calculation, has its own properties. Now, example, understanding the number 718 in Arithmo-Hindi system. So, explain how the digit in 718 represent the total values. First, break down the number according to the place of each digit. Ones place digit is 8 in ones place. So, its value is 8 into 1, 8. Now, tens place digit is 1. So, its value is 10. Now, 100 place digit is 7. So, its value is 7 into 100, 700. So, the total value is 710 plus 8, 718. Now, if the 0 were missing in the numbers like 708, we would like to, it would be written as 78, completely changing the number value, because they two are different numbers. This demonstration of clarity and efficiency of the Arithmo-Hindi system. Now, why it matters? The combining of base 10, positional value and 0. This system of the arithmetics systematic, reliable and scalable. It eliminates the need for the countless symbol. So, it needs just 10 symbols, 1 to 9 numbers to represent all the numbers. It eliminates the need of countless symbols, allow the computation and provide a universal language for the number. Today, all modern mathematics, science and finance and engineering rely on these principles. Next is learning point 3.4. Practice all the questions. Next is summary. Counting begins with simple method. Such a tally marks, stones and the finger symbol used to by the early humans to track animals, goods and daily activities. Different civilizations created their own number system, each with unique symbols and the rules such as the Egyptian, Babylonian, Roman and Mayans. The Egyptian number system used picture to the power but did not use the place value, making the large numbers long and repetitive. The Babylonian system was highly advanced because it used the place value and the base 6 structure, which survive today in close. The angle, the Mayan number system built the base of 20 is used dots, bar and shell symbol for 0 arranged vertically. The Mayans made the unique modification by using 360 as the third place value to match their calendar calculations, showing the link between the math and the real life. The Roman numerals used fixed symbols. In the Roman numerals, there were fixed numerals like I, V, X, etc. but had no 0. But there was no 0 and no position value for the arithmetic difference. The idea of number base means the place represents the power of the base. Like example, base 10, ones, tens, 100. Place value is one of the most powerful invention of mathematics because it allows large number to be written clearly and compactly. The digit 0 originally appear as the placeholder and later become the number of its own with the mathematical properties. The Arithmo-Hindi number system merged three key ideas: a base 10 position value and a true 0. The system used only 10 digits 0 to 9 to represent any number, no matter how big, making it universally efficient. The spread of this system through traders, mathematicians and the scholars led to its adaptation across the world. Modern arithmetic operation and are simple and systematic because of this number system. Today, the digital technology, computing system and the scientific calculation depend heavily on these concept of base position of 0, making the evolution of number system one of the humanity's biggest intellectual achievement. So here we end the chapter. In this chapter, we have learned about the number system, how it gradually depend, what were the limitation of earlier system, and how it gradually become the the number system which we use now. I hope this chapter is clear to you. Now to practice it.